the Coastal and Marine Management Systems class. And uh, I'm doing my video on Mugu Rock and the relocation of the PCH. Pretty much everybody's seen Mugu Rock, especially if you've driven down the PCH. It's kind of hard to miss. It's this massive chunk of volcanic rock with a highway blasted right through the middle of it. Most people drive by without even thinking twice, but this spot has a pretty wild history, and it's still shaping how the coastline behaves today. When they first were building the road way back in the early 1920s, engineers had a problem. The ridge stuck straight out into the ocean. Their first idea was to wrap the road around the seaward side, and you could picture a skinny little road hugging the base of the rock and waves crashing right next to your tires as you go around a blind curve. And storms were constantly chewing away at this little road that they cut out. It was dangerous, and people actually called this curve Dead Man's Curve due to the amount of loss of life that was happening around that area. Eventually, in the 1930s, they decided to stop fighting the outside forces and just blast through the middle. Crews came in with explosives, carved out a 60-foot wide and about 200 feet deep straight through the ridge. And that's what you're driving through today. It made the route straighter, safer, and it pulled back the road a bit from the exposed edge. The old road wrapped around the outside. The old road that wrapped around the outside slowly was abandoned and slowly started disappearing into the surf. If you know where to look, you can still spot some traces of it along the shore. But the highway alignment we use today has been there ever since. And that decision kicked off a chain of changes that are still playing out. When they blasted through the rock, they didn't just change the road, they changed how waves hit this part of the coast. Originally, the rock had a sloping face, which helped absorb wave energy. And once it was cut vertically, waves started bouncing straight back. That reflected energy outwards, and it ramped up the erosion on either side of the rock. And you can see it if you look closely at the base of the cliffs at the undercut rock. And you can see sections that are breaking away over time. It's like a mirror for wave energy, and it's hard during these big storms. Mugu Rock also sits in a zone where sand naturally moves down the coast. By slicing through the ridge and laying pavement there, we've created sort of an artificial headland that changes how sand flows. Some areas get starved, others erode faster than they would have naturally. Over decades, that's reshaped the beaches around here. This area is already known for some of the fastest erosion rates in Southern California. The cut itself forces energy on the edges, which just speeds everything up. The cliffs right next to the highway are part of that retreat. Over time, that puts the road itself at risk, especially during those big winter storm seasons. Then there's the ecological side. The blasted rock faces don't offer the kind of gradual, complex, intertidal habitat that natural slopes do. Instead, tide pools, crevices, and transitions, it's just a vertical wall. Uh, Pair that with sand starvation and erosion, and you've got beaches and dunes getting squeezed between the ocean and the highway. As the shoreline moves inland, there's nowhere for those habitats to go. That's what coastal managers call coastal hardening. To keep the road stable, they've added more hard structures over the years, retaining walls, a thing called riprap, stabilization. It works for protecting the road, but it also pushes wave energy somewhere else. It's like squeezing a balloon. If you fix one section, the problem's just going to pop up down the line somewhere else. It's a constant game of defense. And just down the coast, you've got Mugu Lagoon, one of the most important wetland systems in the region. The changes happening here can ripple through that lagoon in shifting sediment flows, wave dynamics, and shoreline positions all interact with how that wetland functions. This isn't just an isolated engineering site, it's part of a bigger coastal system. Right now, the approach here is pretty much hold the line, reinforce what's already here, keep the road open, patch what breaks. Moving the highway inland isn't really an option anymore. You've got that steep terrain on one side and the Navy base on the other side, so there's no easy path to relocate. So managers are working within those limits using the tools that they've got. But as sea levels rise and storms keep getting stronger, the trade offs are getting more sharper. Protecting the road often means doubling down on hard structures, and that can actually lead to more habitat loss and more erosion somewhere else. At some point, the question shifts from how do we defend this spot to for how long can we keep defending it? Mugu Rock is a perfect example of how one decision, in this case, blasting through a ridge and making a safer road, can shape a coastline for nearly a century. It's solved that problem at the time, but it's also set off a series of changes that we're still dealing with. And with the pace of coastal change picking up, this spot is going to keep testing how adaptive and creative our management strategies really are.